All right. Welcome to episode 27 of Roid Rage. We are going to talk about structures. So naturally, we brought our head of space systems to talk about structures.
Wait, didn't we already talk about structures?
We've talked about structures so many times, but this is going to be a different tact on structures. I actually think, Rachel, you can fact check me. Structures has probably been the most popular topic on podcasts so far in terms of frequency.
Well, because we keep doing it, so why don't you just call it something different?
Like screws.
Like
Screws.
Okay, cool. We're here to talk about screws today.
Screws.
Okay, that's not structures. So
All right,
great.
over to you, Ashton. Screws.
Tell us the history of screws.
Screws are really important. They hold things together. And you want to have enough of them so that your things hold together under all sorts of different loads. For example, bicycle seats, racing seats are held together by this little C-clamp on some designs that are held together by one screw. If that screw breaks, your seat's going to fall off.
Why don't they rivet it?
You know, we can take that up with them.
Because then you can't take the seat off.
Yeah, you want to be able to take it off, slide it back and forward.
You got to be able to adjust it on the fly, unfortunately, because it's a...
I was making a way worse joke.
Yeah, I know. I was trying to save us from that joke. Thank you. I came back and said, no, let me double down on that joke. And I was like, please. Sorry, back to you.
Well, I was taking a bike like that to class one day in grad school, and that screw broke. My seat fell off. I was wearing flip-flops. My foot hit the pavement. Flip-flop stopped. Foot kept going forward. My foot did a 180. There's a picture of it. It's pretty gruesome. Bone almost popped through my skin, but had to have reconstructive surgery, and now I have 3 screws in my ankle holding it together.
So it's like a 3-for-1 trade.
Yeah.
But that's not really the screw's fault. That's a shitty bike seat.
Well, no, it's actually his fault for wearing flip-flops bicycling.
Yeah, actually, I blame you, Ashton, 100%. I'm with Robin.
Well, the bike was abandoned. I just picked it up and started riding it one day.
I hope you abandoned it.
I did abandon it afterwards.
Yeah. Although nobody wanted it because I had blood all over it. Jeez, man.
It was brutal. So screws are important. They hold things together. And when they fail, it can be pretty violent.
Yes. I mean, just to say, I know that's really particularly, but I also did a race one time where a guy broke his seat and the seat post impaled him in his thigh right up by the femoral artery and went up and dislocated his hip. So,
wow.
How? How does that even happen? Like, don't you fall off the seat? Like, what the fuck?
Well, no, because to Ashton's point, like the C-clamp, you can either have a single screw or you can have a double screw. So a double screw will allow you to anchor it into place and then adjust its tilt, basically. And a single screw will allow you to do that.
This seems like an industry ripe for being overturned with a new design.
The screw, like you have to clamp them generally anywhere between 10 to 15 Newton meters with force. And it's on, generally speaking, carbon fiber rails. So they are really strong. And the moment you apply torque in one direction, you can snap your rails or you can loosen the screw. And then your seat post just becomes spear.
A pike?
Yeah, literally pike.
Ow.
Yeah, but that doesn't happen on our spacecraft. We'll bring it back to spacecraft. Aside from like really bad injuries that we've just appalled all of our listeners.
Blood and gore podcast. Jesus Christ.
This is what they dialed in for.
Yeah, so screws are an example of like all of the small things on the structure that we talk about. Like we oftentimes, I think we've talked about mostly from a structures perspective, like primary, secondary structures. We thought about it. There's big things like the actual like bus and then the solar panels. We want to spend time this time on what are the small parts of those structures and why do they matter? So screws are an example. What else are the small parts that matter?
Yeah, we kind of bundle that into category of hardware. So screws, washers, nuts, in little
shipping standoffs.
Standoffs for shipping, which
we screwed up.
You think, yeah.
Yeah, no, we totally screwed that pooch on that one.
Yeah, but we're fixing it. Epoxy too.
He doesn't want to talk about it.
Subject change.
And epoxy too. Yeah, okay, keep going. No rivets though, huh?
Lubricants. No rivets so far.
All right, just opportunity for weight saving.
Yeah, panel inserts. There's helicoil inserts, these little coils you put into a threaded hole. There's all sorts of small parts that you don't think of when you first think of a spacecraft that actually need to go to put it together. Details.
Or we don't think of when we're going to ship it.
Yeah.
Like last week.
Right.
Seems like you want to talk about that, Robin.
We don't have to talk about it. All I'm saying.
I feel like the people need to know.
Yeah.
The people need to know that we totally screwed the pooch, and looking at the clearance between our spacecraft and its shipping GSE.
Yeah. So we integrated the prop system.
Okay.
And to get the assembly back to our office, we had this ground support equipment, Robin's calling GSE, to ship it, and we had some interference with some of our flight parts with that GSE that we had to deal with.
Yeah, let's just say Robin doesn't call a lot of Sunday afternoon meetings.
Yeah.
We had a Sunday afternoon meeting. Yep. All right, I got that off my chest. Hey, Matt wants to talk about
Part of recovery.
Yeah,
Part of recovery.
Matt wants to be totally transparent. Here's the real problems, right? Screwed the pooch. You got to clean up your mess.
Yeah, we also, let's be honest, we screwed the pooch in a lot of ways on this. It wasn't just that the standoffs were wrong. So we put the thrusters on the bottom of the base plate, which we've sent a whole bunch of pictures. If you don't know what that looks like, look it up.
Yeah, at this point, if you're listening to this podcast and you don't know about the base plate, like, you should really question whether you're listening to this podcast.
Yeah, you should probably hit next on a little player. But we did that, and
because it's not getting better. This is it. This is as good as it gets.
The thrusters were too long, and they hit the bottom of the box, right? And so when you have something like that happen, you take a lot of steps back and go, hold on, how did we get it so wrong? And we got it so wrong for a number of different reasons. There was quite a few problems we discovered when we went through on this to say, where did we make the mistakes of not only the ground support equipment being mounted to the spacecraft, right? This is flight hardware. The procedures we used were inaccurate. There was some mistakes made along that way. But also, how do you just get something so big so wrong, right? Like, how come it's not tall enough? What did we do? And it's led to a lot of discovery that we had past weekend on what we need to change.
It's good times.
The good thing is it's all changeable. But this is really how spacecraft building works. It doesn't work. And if you talk to any company that goes through this, you fuck it up all the time. And it's really important that we can pull everybody together and fix it at a high rate of speed as we go into it. And I think in this situation, that's what we did. We're all getting on a plane tomorrow to actually go visit it and make sure it is okay to ship back, because the worst thing we want to do is fuck up our engines because we shipped it back erroneously. Once that's good, though, we'll be back here, and there's, I think, 2 or 3 fixes we need to make to the spacecraft, and then we're right back on track to be producing it.
Who knew that Matt was going to be Mr. Positive in this episode?
I'm always Mr. Positive.
That's factually incorrect.
All right, we'll let Ashton talk about screws.
Yeah, well,
and epoxy.
What people
Rivets.
need to remember is we're building a pretty sophisticated piece of machinery in vestry, but as complicated as it is and high tech, it still is a prototype. It's the first time we're doing a lot of this stuff. We've learned a lot from Odin and from the spacecraft before, but first time we're mating a Hall effect thruster to this base plate was this time around. So the fact that we're going to get it wrong here and there on the first time is expected, like Matt's saying, but ultimately...
Oh, I never said getting it wrong was expected. We got to get it right.
Well, yeah.
There's the Matt. There's the Matt we know and
Getting it
love.
wrong was expected.
Yeah, I mean, eventually we're going to get all of it right.
I mean, eventually by the time we launch, we get all of it right. Yes.
Yeah, and by the time we build the next one and the next one, each one's going to get faster, more efficient, cheaper. Anyway, small pieces of hardware. What do we want to know about it?
Let's start first. You're the head of systems. Why is it a system? Is it a systems problem? Is it a structures problem? Like what? Like help us frame this.
Ultimately, specifying these fasteners, purchasing them, making sure that they have the right torque values. It's all on the structures team, but it's going to be the integration.
So it's actually not your responsibility.
No, it's
Oh.
not.
Here.
I don't know.
Should we have our first live
Should we audible?
performance improvement
Yeah,
plan?
can we just audible and get a structures
No.
person in here?
To be clear, it would not be the first. I think we've already done a live, or at least we've threatened.
No, we've threatened live.
Yeah.
Yeah.
Oh,
but
you
we-
want to actually conduct one.
I was like, sounds like it's not his job. Like, what is your job?
Hey, what do you do here, Ashton?
I ask myself that every day. I try to make this work, try to get it built, try to get it tested. And it is the responsibility of people on my team to make sure that these screws actually go in the right places.
Maybe even that they're the right length.
That they're the right length.
Just as maybe another painful example.
Well, and you're cheating too by saying it's all structure's fault. It's not, right? There is still plenty of things we order that require very specific screws. I mean, what was the example of the thruster screws that we need? We need to get very specific screws.
We're going to use aluminum, right?
Titanium,
Oh, not nylon.
not nylon. Yeah, definitely not.
Okay.
So yeah, I mean, when we're working with some of these systems that we've purchased off the shelf and even ones that we're designing ourselves, it's not as simple as, get any old screw that is going to fit in this hole. There are a lot of design considerations you need to take into account when you're
Although
specifying
these
that.
days I'd settle for fit in the hole.
Fit in the hole would be a good start.
Yeah,
for
yeah.
some of the stuff that's happened.
Yeah, okay.
But yeah, we're using titanium fasteners on the Hall effect thrusters for various amount of reasons.
How come?
Their strength, for one, but primarily it's the relatively low thermal conductivity of titanium with respect to or compared to stainless steel or aluminum. So the thruster gets really, really hot. We don't want that heat coming back into the spacecraft. So at every interface from the thruster down to its adaptive plate, to the gimbal, to the bracket, to the base plate, all of those, we want to minimize the heat traveling through there. And titanium is a good material for that because it is as strong or stronger than stainless steel, but it conducts heat much less efficiently.
Okay. That's an important detail about a screw.
How many different screws go into the spacecraft?
Too many.
Oh man, this is where Matt goes on
This is where I
rage.
bitch
This is the rage.
24/7.
This is the rage part of Roid Rage. Matt, how many kinds of screws do you
There should
think we
be
need?
fucking one. But structures people don't like to build with one screw. I really have pushed for standardizing both thread count and length and size of screw. There's a lot of reasons why across the board. The SpaceX RPUG, which is what we follow to build the spacecraft, specifies different mitigations needed for screw sizes. So you don't want to put really tiny or really big screws on because they'll deliver certain things you have to do if you remove them. But also simplicity. As we go through, one of the most frustrating things we had with Odin is you take a panel off and like every fucking screw is a different length. And so now if you want to have 8 holes, you have to have 8 different screws, which you need to have 8 backups for. And like it becomes an exercise in who can collect the most screws. Right? And like, I'm always thinking about how do you have more efficiencies as we go to build this. The way that spacecraft get cheaper and get faster to build is not magically that we build the first one and we learn how to build the second one better. That's part of it. The other part is how do we standardize it, right? How do you think about minimizing the number of different parts on the spacecraft? Screws are one of the biggest different parts we have. And to structures like hating me, I'm constantly asking the question, do we need helicoils? Do we actually need this screw? Can we remove this? What can we do here? Because all of that is time and materials and cost and labor and tracking that we have to follow up with. And Robin loves these things called like ERP systems or inventory or something. He's always talking about this shit, right? He's always using some acronym that I don't want to memorize. And the reason he loves that is because there's so many fucking little parts that you have to track it all. The real goal I want to drive us towards is to minimize that as much as possible. But there is a bottom limit there. We're probably not going to use 2-inch, half-inch wide titanium screws on the whole spacecraft. That probably doesn't make any sense. So like, okay, we already need 2
Actually,
there.
what you said just makes no sense.
Yeah, so that's not a real screw size. But
Yeah.
most of the people that listen to this are investors and they have no idea about screws. They run like car companies or something. The other thing is that we want to make sure that we buy a lot of parts from people, right? And so like our valves require a very specific screw size. We actually don't want to use that on the rest of the spacecraft. So we'll make that a different screw size as we go in to hold our valves down. The avionics will need to have special screws. And then you get into the materials, the coatings, the type of heads they are, how you install them, are they countersunk? Like there's a lot of details for a screw here. Go to your standard hardware store, right? Look at any bolt size.
Oh
and
man, I love the fastener aisle of Ace Hardwares.
You go to Ace Hardware, it's such a ripoff, dude. Go to Home Depot. It's like half the price and you don't have to deal with I hate Ace Hardware. I never go to that store.
You know why I go to Ace Hardware? Because they actually have the screws I want. And Home Depot, you open up the box and you think you got it and you reach in and it's like something from like 2 drawers away. You're like,
oh, usually it's just stolen, but okay.
Yeah, it's just stolen and not available. And like if you like, oh, but look it up in inventory before you go to the store. And then you do, and it's not right. It's not there. They don't have Danny the Dino. They don't. It says that they do. They don't.
Yeah.
You know how disappointing that is to your daughter?
I got no comment.
So
All right.
we're not at one magical 2-inch titanium screw that has a counter thread, according to Matt. How many, like directionally, are we 20, 50, 100 different types?
Probably between 20 and 50 when you take into account all the different types.
The fuck? We have a design review on screw types?
I guarantee it's more than 50.
Oh,
More than
Jesus
50.
Christ.
Oh,
Can we have 2 design reviews?
This feels like a fun.
This feels like another Sunday meeting.
So Robin is more than 50. You think 20 to 50?
Yeah. maybe with more thought, I'll tend towards the higher end of that.
All right, we got a $1 bet. Over,
I was
under on
saying we
50.
put
I'm
thought into
over.
our screw
Ashton's
sizes,
under.
So
50 is a nice round number, too.
Okay.
50 seems like a lot.
It's a lot. I'm not happy about 50, but I bet it's more than 50.
How does that compare to like the number of small, like what you would consider small parts on the spacecraft in total?
Well, the only parts smaller than the screws are like the components on the PCBs, like the resistors, capacitors, processors.
what about helicoils?
I guess they're smaller.
What about washers?
No, the helicoil by
What
definition has
dimension?
to be bigger than a
Yeah, I guess
screw.
so. Yeah, it may be lighter, but it is physically larger in at least one
I
dimension.
guess dimension. We have to care about dimension.
So it's among the smallest of parts.
Hey, by the way, like helicoils are an important thing, but it's not like there's one kind of helicoil either.
No.
I just got to I'm going to give Matt antacid.
Do we have more than one type of helicoil on the fucking spacecraft?
I hope so.
We have at least more than one size.
Okay.
For those listening, a helicoil is an insert. that
Those
goes
still
into a
listening
hole.
is what Ashton meant to say.
And they're used to. I don't know why.
Oh my God.
You don't even know why the fuck we use it. I know
Well,
about
he's
the-
not a
It's
structures
retention
guy.
mechanism.
No.
If you screw up
No.
the threads, you can take the helicoil out, put a new one in.
It's because we use helicoils because we're screwing into aluminum, and aluminum is very weak. And when you pull out an aluminum bolt, a lot of times you'll chase the threads coming out. You'll remove the thread. So you use a helicoil so you can screw into steel and put one. I don't know the structural term. One thread in on the aluminum and leave it in. That's the whole point of a helicoil. That's why they're used on like engine blocks, things like that. They're also used on our base plate. Or we could just be better and assemble it one time and not have to use helicoils. But
We're not better.
yeah, nobody wants to agree with me on that one. I'm fighting an uphill battle by myself on this one. I'm really trying, but it's gotten zero traction.
If you really want one install, use rivets.
I mean, I'm down to make this like a 1930s aircraft with just fucking rivets everywhere.
There you go. All right, what's the next question?
You were going to say there's more than one type of helicoil. We've established what a helicoil.
Oh, yeah. So, I mean, obviously there's different sizes for different screws, but there's also different lengths, but there's also different materials on helicoils depending what you're putting them, your receiving material and your screw material is. Oh, there's also locking versus not locking. There's also tanged and tangless helicoils. And then if you really want to get crazy, there's other self-retention methods like spiral lock, which is a proprietary kind of thread form that they also have helicoil and key insert styles. Like, it's not just the screw. It's the washer, it's the screw, it's the nut, it's the helicoil, it's the material you're putting in. It's what, are you installing the helicoils wet or dry? Are you going to get a galvanic corrosion issue? Is this intended to be a ground point? Like, all of these little details matter. And I think that was really the point I wanted to make in terms of like, why do we have more than 50? That's my dollar bet, screws. Because we need more than 50. And we should be designing for manufacturing and reducing that count as much as possible. But if we need more than 50, we're going to have exactly as many as we need.
We don't need more than 50. We want more than 50.
No, I want less than 25.
That's within my range. 20 to 50.
All right, let's go see. Dollar bet.
Less than 10.
Less than 10.
Then we don't need an ERP system.
I'm not going to get in between you two on the ERP. That's outside of my.
Well, it's not even the right system. I'm just letting it go. Enterprise resource planning is not materials resource planning.
Whatever.
But he's trying to jab me, and I recognize it.
I
So I'm
don't
going to
wanna-
let it go.
I don't want to actually learn the difference between those two things. So I'm just going to call it all ERP.
All right. So we talked a little bit about screws. What are the other sort of like small pieces that you have to worry about from a systems?
First off, can we stop calling them screws? They're bolts.
Are they
Like-
fasteners?
They're fasteners, I guess is the better way to put it. I always think of a screw of like little pointy end, like a Phillips screw that you put into a picture frame. Like that's not what these are.
Okay.
Right? These are
You hope.
Well, actually, now knowing that we have like 150 of them, we need to review it. But
Oh, now he's up to 150.
I hope they're not. These are like highly tested and machined articles, fasteners that we use with very tight thread tolerances and things like this that go into it. They're pretty
Help us out, Ashton, man. Take us somewhere other than screws and bolts and nuts and washers. Anywhere.
Small things like harness backshells, connector
Ooh,
backshells.
yeah.
Backshell. What's a backshell?
There's something held together by screws. No.
Chad, throw him a bone.
No, backshell. So we have a lot of harnesses. There's a lot of wires. Probably too many wires on the spacecraft too, ultimately.
What's the over-under on wires?
We have fewer than we could have had, though.
Fewer than we could have. Over 1,000
Oh my God, let's meet on Saturday.
individual wires. Yeah. These wires are all bundled up into what are called wire harnesses or harnesses, cables, you could call them.
Looms.
They get terminated in connectors. They plug into boxes. The place where the wire joins the connector, typically it's either a crimp or a solder joint there. Those are kind of fragile. And as you handle these harnesses, you can rip those out. And so what a backshell, one of its purposes is to kind of provide some structural rigidity at that fragile point around the solder joint. So all of our harnesses have backshells at the connectors so that they're nice and rigid and we can handle them without ripping them apart. And those backshells are expensive and small.
How expensive?
Too expensive. They're like $300 a pop. You buy them in bulk.
I really wish you hadn't said that out loud.
But what happens when we don't put a backshell on a harness? Have we ever made that mistake before?
Yeah.
Or you put a backshell on, but not connect it. Just let it free float on the wire.
Has that ever happened before? I'm pretty sure a CO wouldn't let that happen.
Yeah, no.
Yeah, no. I think a CO would fix that.
Yeah.
Okay. Next question.
I don't think you told me his answer.
Yeah. So on Odin, we had a backshell that didn't really fit.
Yeah.
And Matt came in.
Oh, no, we're not talking about Odin anymore. We closed the chapter.
Yeah, we
on Odin.
turned the page on.
Yeah.
Yeah.
Factually incorrect, but sure. Keep going.
Always learning. Odin's still out there chirping to
He is.
someone.
Yeah.
It is.
I kind of hope at some point, like it just spontaneously combusts and someone picks it up and thinks it's an alien.
Sorry, just to walk this through. How would it both?
I don't know.
Somebody picked up this alien?
We managed to light it on fire in the office plenty of times, so maybe it magically lights on fire in space.
Again, things I wish weren't said out loud.
Did you guys see the new study on the alien object that they released the paper saying they thought it was powered? And now they came out and said it's leaking carbon dioxide.
I saw some headline that they thought it was nuclear powered.
I love reading the headlines because you just read the headline, they're like, nuclear powered spaceship. And you're like, fuck, this is awesome. And like a day later, never mind, it's just CO2.
Yeah.
So maybe that'll be Odin.
We'll come back one day. I was thinking it's out there somewhere. It probably is on a trajectory that will bring it close to Earth at some point.
It's not. We planned it. It's a trajectory that does like a cloverleaf between Mars and Jupiter until our simulation ran out of time.
Oh, okay. Well, that's still pretty cool.
Yeah.
Even cooler if we could hear it.
Or see it.
Small parts.
Yep.
Things are mostly bigger than screws and fasteners and backshells. What else?
Yeah, but there is also.
What about like
the
paint
The
kept on tape?
connectors, the
Yeah.
connectors have standoffs on them and screws on them to hold them together. The connectors are actually pretty detailed parts. And if we look at one single connector, I mean, how many parts are in that connector?
At least a dozen. And you've got the metal enclosure, you've got the dielectric insulator, you've got the actual contacts that carry the electrical signal from one end to the other. You've got
The pins.
the pins.
I feel like you're justifying how expensive they are.
Hopefully nobody from our vendors is into this. But no, they're too expensive.
They are, but they're important.
Seriously important.
Yeah, then we have my favorite thing, capped on tape. The reason I love capped on tape is for no other reason. As soon as you put it on stuff, it looks more spacey.
Oh, man. Today's just one of those episodes.
It's true though. It does
It's
look
true,
cool.
right?
is,
It's
yeah,
true. As
yeah.
soon as you put that yellow capped on tape, you're like, oh, this became space.
I think of it as it's like the kid in Little League who.
All right, give me the
black,
script.
and then you were just like, "Oh, you're automatically better at baseball." And they're like, "No, you just bought eye black. That's all."
Did you wear eye black?
So you weren't good at baseball.
It's quite good, but it,
There's the logic puzzle. So if you don't put Captain on the spacecraft, it's not a spacecraft?
yeah. Is that the definition of a spacecraft right now?
Every spacecraft I've ever seen has had a fair amount of Kapton.
But no screws.
But why?
There was actually a student from Cal Poly who did his whole master's thesis on Kapton and all of its properties. It's like a wonderful material. It's got great thermal isolation. It's a very good electrical insulator. It happens to hold things tight.
It's just yellow Scotch tape, right?
That's rated for spade.
What honestly makes it different than Scotch tape?
Color.
Oh man.
No, it's polyamide. I mean, it's used actually not only in tape, it's used in a number of different applications. It's just a great material, but I'm not a material scientist, so don't ask me anything
I
else.
didn't know Ashton had like a love fetish with Kapton tape.
I learned it from you.
You know what's really great about Kapton tape? It costs a lot.
How much is a roll of Kapton tape?
$10, $12,
For how wide though?
like 1 inch.
Yeah. What about 4-inch?
4 inch is gonna be that's $40.
Not too bad. Yeah, what about MLI?
MLI stands for multi-layer insulation. It is actually made of Kapton,
It's not. It's made of gold.
a gold-plated Kapton. Well, you can. I mean, there's a million flavors of MLI. It goes back to the fastener discussion, helicoils. There's a lot of different parameters you can tune, options you can select when you're buying this stuff. But basically, you use it to keep the heat in when you want it in and heat out when you want it out. So it's a convenient and efficient way to control the thermal environment on your spacecraft. Although I would say that's actually a pretty large piece because we cut them in huge sheets of meter by meter size and trim them down, sew them into the geometries that we need. Yeah, we got that. We got silverized Teflon tape also for radiators. We got the paints that we use for also thermal control. So what about MLI?
I got nothing. I don't know. We started to go from small components like screws to fucking blankets. So I don't know. Chap,
Yeah.
bring us back.
So, like, where in the design process do all these small components come in? Like, do you think about them when you're designing base plate?
And clearly
Is it
not if we have
after
100
fact?
of them.
Not
Aside from
really
that-
enough.
Okay, so where do they come in now, and where would you like them to come in the design process?
Right now they're coming in. Oh, hey, we're gonna build this in a week. Like, do we have the fasteners we need? And then we haven't thought about that yet. So
Got it.
let's think about it.
So more of a just-in-time.
Yeah, and ideally, as you're designing the base plate, as an example, you are selecting the fasteners and doing the diligence you need to do to make sure they're the right ones at the time. Because when you design something and leave a whole bunch of to-dos, a laundry list of things you need to come back and do, oftentimes you're going to miss some of those actions when you actually come back to close things out. So my philosophy is just to finish it all when you're doing it. Don't rely on, Ashton a week from now is going to figure this out.
Yep.
That's future meets problem. So it should be done as the design is maturing.
What do you think prevents us from doing it as the design is maturing right now?
Hurry up, Ashton. I want the answer right now.
A lack of consistent process. It's up to right now. It's up to everybody who's designing their parts to do it as they see fit right now.
Yeah.
So we need a little bit more structure.
This is the systems guy talking about the system and then delegating the responsibility of the system to everybody else.
feel like I
and
threw
then
him a
saying
bone.
We need more systems.
Didn't I just throw him a
That's what I
bone?
literally just said. We need more structure to our systems approach as the head of systems.
Mm.
Were we talking about that PIP thing?
I can't believe you used an acronym.
Fuck, got me.
Yep.
Are we done?
Sure.
Is there what else is on this script? Is this it? Is this
mean,
what we've lowered ourselves to? Hey, here's a real question for the viewers.
Yeah.
Or I guess we're not viewers, right? The listeners.
Some are viewing. There's cameras in here.
I thought Rachel broke them.
Some are
None
some
of these
flash
fucking cameras
red.
are on. Oh, I guess they're flashing red. Cool.
So I'm just assuming they are on.
Oh man, that's information I wish I had really thought about. Anyway, no, here's a real question. Like, is having a discussion about screws or the equivalent once a week, is that really the helpful thing? Like, we've gotten some user feedback on different topics they would like, but like, we really haven't asked about frequency. Like, would it be better to have a deeper, longer dive or like stay at the once a week kind of format? And what are we doing? Like 45 minutes, an hour?
You're talking about the podcast or screws?
Oh man.
Rachel, how many listeners do we have?
We don't have subscribers. It doesn't quantify it like that. We have over
I mean,
10,000 listens.
That's not true.
10,000 listens total?
Yeah.
How many per episode?
Around 300 to 400.
Okay.
About 50 of those are me. Played on repeat.
Do you play it on repeat just to give us numbers?
Dude, spend more time on screws, less time on Roid
Yeah,
Rage.
or systems or whatever the hell you do here.
More process.
But no, please email us at, I don't know what our chap@astroforge.com. Any recommendations you have for the podcast that we could make better.
Cool. That email it doesn't exist, so you might want to try another.
Chapman at this guy.
There you go.
Rachel at AstroForge.
For another buzzsaw that Ashton can walk into, what hypothetically, if we used fasteners that were not mechanical but required some
I
sort of
feel like the buzzsaw
adhesive,
was brought to him.
what would those be, and how could those possibly go wrong?
Well, maybe you're talking about epoxy.
It's a good
I
example.
really
of,
hope we don't edit this episode. I hope this just comes out raw.
So tell us more about epoxy.
It's just glue, right?
It effectively, yeah, it's just glue that is more expensive.
I can't believe you said just.
We're not allowed to say just.
That's right.
It implies an oversimplification of details that aren't thought of through.
There you go.
When you say we, who is we here?
Robin.
Cool. I wasn't sure if we had like a new company philosophy that hadn't been actually told to the company.
Yeah, don't
but-
lick the terminals of the lithium-ion battery, and don't tell me just. We're just going to do something. You know what just going to do something is?
Sir, why are those two things related? How is just in licking a terminal of a lithium-ion
I'm
battery?
just going to see if this battery still has any power left in it.
They can be used in the same sentence. That's how they're related.
So back to the epoxy that didn't cure Ashton.
Epoxy is either one part or multi-part compounds that you mix, and you put it on parts, and hopefully it holds them together. Hopefully, yeah. We use it on fasteners that don't have secondary retention mechanisms, which is a technical detail.
So we just glue the fasteners in.
We just glue them in
It's like belt and suspenders.
on the small ones, yeah. We also occasionally will glue heaters down or the wires to the heaters down with epoxy. We use a 2-part epoxy called 2216. It has a special applicator gun that
What are the two parts?
part A and part B.
Oh, man.
Shows we have a lot of detail there on the two
So there's a special mixer gun, though.
There's a special mixer
Why is there
gun
a special mixer gun?
because the ratio between the part A and part B is important.
Mm.
How important is it? Like really important?
Yes.
It's pretty important.
Okay, it's pretty important. Okay.
And so people in the room are alluding to
The buzzsaw.
the buzzsaw, yeah. We went to go do our propulsion integration. We had a component that needed to be epoxied down. I had the tube. I did not have the applicator gun. And I opted to...
What happened to the applicator gun?
It was not packed.
Who did the packing?
I oversaw the packing.
I feel like there's like multiple passes in the buzzsaw. Like you've got the 2x4 and you're just like...
It just become the roast of action.
The guy who just wants to cut his fingers off
Yeah,
on the table
just
saw,
getting
one
closer.
finger at a time, just angling it. Yeah, okay.
All right, so I'm going to give him a little breathing room and just make the point that like some small parts of the spacecraft aren't even on the spacecraft.
Yeah.
Like having not only the right mixer gun, but the right applicator for that particular mixer gun are important. That's a small detail that if you forget, you find yourself at a vendor trying to decide whether or not you think you can manually mix epoxy with a stick as
It
if
was 2 Allen wrenches.
I'm so much more upset now.
You ruined good tools to make shitty epoxy.
I don't know. The tools are...
Now, fortunately, we did do the not only gluing of the fasteners or heaters, whatever was being glued in that particular case, but we also did the sample set where you use that exact same material and put it on the side. And then when it's all done, supposedly curing, you go test it and make sure that it is what you said or what you thought it was, and it wasn't. So we caught it.
Yeah. And in my defense, this was a reversible decision that I made on the fly to keep going with integration, knowing that if this failed, the
Yeah, you
hardness
can always
test-
sew your thumb back on once you cut it off
To
with
be
the
fair,
buzzsaw.
aren't all decisions we make reversible? Like if we
No.
fuck it up, we can rebuild everything. That's not the point.
No, they're not all reversible.
Right.
Which ones are not?
Do you really want to go there? I suggest we go to the mailbag.
I'm going to take that tonal cue as no, we don't want to go there. All right, cool. So I think the takeaway from this is there's a lot of small details that come in small pieces that are important that we
And
are
it matters.
still
Like
getting better.
this is a really, really detailed thing, and we can joke and laugh about it. Like, please understand, we mixed epoxy by barely being off in a ratio when we pushed both tubes at the same time and thought it was mixed correctly, and it was off by a hardness factor of 14. And so we decided that we don't want to use it. Like, these are the tolerances you're dealing with in space. If this was epoxy at your house that you use to
You'd never even know.
Flow-
You wouldn't
you
even put it in a
you want
sample
to
cup.
test it, you want to know, who cares? Like, these things are just so unintuitive to people at the level of detail we have to go to, and one mistake can destroy our entire mission. We picked the wrong bolt, it corrodes, it doesn't conduct electricity, blah, blah, blah. There's so many issues that can happen that we can screw up, and like the details here are so important. So even though we laugh about it, we have to have super rigorous details on what are probably 1,000 small parts, and any one of them going wrong means bye-bye spacecraft.
Man, it's almost like we need a enterprise resource planning, materials resource planning,
Or just less than 1,000
manufacturing
parts.
execution system.
I walked into that
could
one.
be true.
You did.
Yeah,
You walked
okay,
into that
yeah,
one.
I got no defense.
All right. Before we go into the mailbag, Ashton, remember you get to ask questions of these two gentlemen sitting to my.
Oh, why do we always
side,
forget
so
this part of the show?
question
Also,
queued up
Ashton's
for
already
that.
been on like 8 times. Does he still get to ask a question?
He still does.
I
There's
never got to ask a question before. I didn't even know this was a thing.
Well, now you do.
Oh, it's not. Let's go back.
Start thinking about some questions. Before
Oh,
we get
man.
there, I want to let everybody know that we now have an official merch shop. Thanks to Rachel.
What?
Uh,
We have merch?
We do have merch. So the first item is up there is a museum grade PGM poster, and we'll be releasing new merch every
Hold on, what do you mean a
Friday.
museum grade poster? It's like made in 8-bit like Nintendo video game style. How's that museum grade?
The paper is museum.
The paper is museum grade.
The paper is museum grade?
Correct, sir. We're only going to be giving away one.
It's a poster.
We're venture backed, all right? Money matters.
So we're giving away a poster to the person who emails us in the best question. The judge in that question is going to be our structures engineer, Holly. And the question should be hopefully around CAD simulations. So email that into mailbag@astroforge.io. And
We
will
that
give-
desperate for mailbag questions?
Can you give us a question on CAD simulation? Like, where are we going with this?
Given the range and breadth of our questions, I feel pretty comfortable someone's going to come in with a good CAD simulation question. So we will see. And they will get a free poster if they
I think
do.
it's a malformed question. I think it's computer-aided engineering simulation, not design, but whatever.
All right. Well, now that we're just picking nits, let's get into the mailbags. This is from Troy. What are your thoughts on access to lunar resources or the utility of Lagrange points, lunar slingshot opportunities, etc.? Those seem like two different questions, so I'm going to break them apart.
I like the
Troy's behalf.
etc.
What are your thoughts on lunar resources? Is there anything there? First question.
I mean, my thought is pretty simply, we don't have any evidence that there's anything super special on the moon that we can go after. The moon is an extension of the Earth. It's at a lot of the same concentrations we see here. And sure, we can find certain elements there but they're not any better concentrations than what we really have on Earth, except for one called helium-3. There's been a couple companies that have gone after this resource called helium-3. Our potential issue with the moon is that it's really difficult to access the moon. You've seen quite a few people try to land on it. It's really hard to enter the gravity well of the moon and land successfully. And then once you mine whatever resource you want to go after at whatever valuation, you have to leave it. Leaving the moon is very non-trivial. One of the really nice things about going to small asteroids is they really don't have a lot of gravity, right? We're talking a 500-meter piece of iron. We're essentially docking. And that gives us a lot of flexibility to not have to have a lander in the way you think of a lander. How we attach is different. How we can refine it is different. All of that goes away on the moon. The moon is essentially Mars. So I'd actually ask you the same question a different way, which is, why are we asking about the moon? Why are we not mining Mars? And people can draw that analysis. Well, like, it's really hard to get to Mars. It's got a big gravity well. It's really hard to leave. And we haven't discovered like a giant pit of gold on Mars. The same thing holds true for the moon. So for me, the moon is not exciting. And I don't really care about it.
I thought it was because our company was named AstroForge.
Well, these could be personal thoughts. They don't have to be company-sponsored thoughts, too.
Oh, okay. Fair enough. Yeah.
So Robin's just about the name. It's not Lunar Forge, it's AstroForge.
Yeah.
Cool. To second part of the question, is there any utility in Lagrange points, lunar slingshot opportunities?
I think that, well, absolutely in lunar slingshot, we absolutely use the moon's gravity well for plane changes and phasing with the asteroids. Absolutely. Of course, we're going to use it. use the Earth's, we'll use the Moon's, we'll use any other body that makes sense. That saves us delta V essentially, or time in the mission. But Lagrange is kind of an interesting question to ask. And the reason it's interesting is because Lagrange point is basically when you have a 3-body problem, it's sort of a gravity potential. It's a location in space where the gravity potential is such that you don't really have to use a lot of propellant to stay there. Like the perturbing forces from the sun, the moon, the Earth are such that they all equal out, and the spacecraft kind of just stays there, like a marble in a bowl instead of a marble on top of a bowl. And what makes that interesting is, for example, if we were going to put a spacecraft in space and leave it there in a good place to leave, to say go intersect a nuclear powered alien spacecraft that happened to be going through the solar system, rather than having to launch it immediately off of Earth and do all the mission planning associated with the launch, you could pre-plan and put a spacecraft in a Lagrange point and have it ready and waiting so that, it's coming. And now you could then do the orbital mechanics to get there from that particular place. And why there versus anywhere else? Just because you wouldn't necessarily need a lot of propellant to keep station keeping and keep it where you want. And it would be easy to communicate with because it would be in a known location and that kind of stuff. So kind of an interesting mission design concept.
That's a shitty business model, though.
Waiting for an alien spaceship? Yeah.
Okay, if we were to go, it would be a little small pivot to talk about alien interception, then I'm agreeing with you. Never mind, I take that back. I kind of want to go after aliens.
Yeah.
Okay.
I mean, I'd lose money to do that.
We wouldn't really lose money. I mean, think about it. If we could become friends with the aliens,
then you win.
then we just come back to Earth and dominate.
Every extraterrestrial movie says aliens definitely want to be friends with us.
I mean, I think it was 1997 when Will Smith took out the mothership, and we learned a lot of technological advancements from that.
Yeah,
absolutely. So,
Yeah. Yeah. Good counterpoint.
Yeah.
Moving on. All right, sorry. Anything to add on those, Ashton?
Well, yeah. I mean, for asteroid mining, I don't think hanging out the Lagrange point makes all that much sense because by the time you launch a spacecraft, it's already obsolete. I mean,
what about being homies with aliens, though?
that one? Makes sense. I agree with you on that one. The
By the
Lagrange points
time
are
you
very
launch, it's
useful
already
for
obsolete.
mission
Doesn't that feel good?
applications.
This feels good.
No, let's go on.
From Anu, what are the most important sets of data that you hope to get from this upcoming mission with Vestry?
Is it made of metal with a lot of platinum on it?
Yeah, we hope to get some kind of composition of the rock itself, right? I mean, there's a whole bunch of data we get on our mission planning, on how our lunar slingshots work, on the whole concept of operations and getting there. There's all this engineering data. From the scientific standpoint, though, we want to figure out what is it made out of? Does it have high grades of platinum group metals? Is it primarily iron? And have we been able to correlate our models on Earth to what we think are M-type asteroids in space? And is that assumption correct?
And are there any alien artifacts?
Yes.
From Starship Trooper, could AstroForge build and send a similar probe toward the asteroid Apophis if this probe and its flight were successful?
Oh, you
Yes.
got to answer this one, Matt.
I mean, the answer is yes, very easily. Apophis is not a difficult on its trajectory coming so close to Earth. It's actually not difficult to make. In fact,
A little too
Osiris
close,
Rex
might say.
was renamed Osiris Apex. And I don't know if it's, hopefully the government keeps it going because it's going to do a flyby 4 days after Apophis. It's not a hard from a trajectory standpoint asteroid to reach. What it is, it's hard from a social standpoint to reach. There's not a lot of pressure from NASA to actually make it to this asteroid. So I hope NASA itself or our scientific endeavors in space don't quit. And I hope we can be on the forefront of making them cost effective because I think we can do it for a lot less.
But I don't think Apophis is that interesting to us because it's not made out of metal.
It's not interesting to the core business of asteroid mining. I think it's really interesting to science, especially if it is non-cohesive and is going to break up. Like there's a lot of models that will start to show it impacting in 2034.
Yeah, we could totally sell that launch.
And like, I want to go find out the science as much as I want to go mine the asteroids, right? There's a piece of me that wants to go, hope we can continue that on.
As long as somebody wants to pay for the science, I'm in.
I'm sure there's got to be a very wealthy individual who's willing to put their name on an Apophis mission.
Oh, they would totally get to rename it. And then they could name all the features on it after their kids and relatives and financial
Yeah,
advisors.
so if you happen to have a net worth upwards of, I don't know what the limit is, probably 4 billion, 5 billion, and you have
Upper
billion, above 5 billion.
Oh, got it.
Yeah, and you have
Yeah.
more than one child, so we could name all the chunks because I think there's going to be like 4
Yep.
chunks from the model I saw. So you need to have at least 3 kids or 2 kids and a dog. And you want to give us $100 million, you can write me at matt@astroforge.com.
Okay.
And if it's less than $100 million, write Robin at astroforge.com because I still want to know.
All right. From Micah. Howdy. Rachel's theme song last episode brought a tear to my eye.
We have a theme song?
Knew that.
The fuck is our theme song?
No, it was the dramatic song that I put behind Robin's feel about how inspirational.
You add audio effects to this?
No, it was because he specifically.
Tell me you don't listen to the podcast.
Oh, I don't listen to this
without telling
podcast
me.
ever. I don't want to hear us.
Don't listen to the podcast.
Hold on. What song was it?
It was
Well-
just like a royalty, like instrumental, interstellar instrumental.
Some AI generated bullshit? Okay.
No, it actually hit the mark because the entire question is, howdy, Rachel's theme song last episode brought a tear to my eye. How much time is spent playing Kerbal Space Program to determine potential orbits?
Oh, man. Why didn't we think of that? We could have been saving so much money.
Does this mean I could fire the systems and orbit team? That was a
Just
nervous
the
laugh from
orbit.
Ashton.
I was quite like, oh shit. He's like, so I spend a lot of time playing Kerbal Space Programs.
We have the professional version of Kerbal Space. It's, we have.
It's called GMAT.
Yeah, we have some qualified software for doing quite complicated orbital mechanics and mission
Yep.
design.
Okay. So we built our own game is basically what I'm hearing.
We mod an existing game.
I wish we had time to play video games, but the reality is we don't. We got to figure out if we can. And
What was the last
Kerbal's
video?
hard.
What's the last good video game you played?
I tried playing that Expedition 33. It's like an RPG that came out pretty recently, and I played it for like 2 hours, and then I forgot where I was, and I don't remember the story anymore, and I'm already over it.
That's the problem.
That's the problem is I get distracted, and then I'm not. Yeah, it doesn't work.
Mm.
I just have. I don't want to say no. It's not no time. I have no attention.
I'm sorry, what?
I have no attention span. Yep. Damn, I fell for that one pretty hard right there.
From Levi, with everyone wearing so many hats, how do you identify when an area needs more people, and how do you find A players in that area?
We have them on the podcast. That's a Robin question.
that's a me question. Oh man, I'm not even doing my job. Oh man, I walked into that one. All right. Okay, the real answer is you have to look at the overall program and look at what activities are going to be happening and what kind of designs are going to be needed and what kind of testing is going to be needed. Look across the skills matrix of the people that you have and whether or not they have the skills or are going to learn the skills on the job while you're doing it. Or do you have to go hire consultants because they can train the people, or it's a skill that you don't need in a recurring way, you just need it in a non-recurring way. And, it's a spreadsheet.
I fell asleep like second sentence.
It's a spreadsheet.
Okay.
It's
Spreadsheet.
actually a very intentional team building process. It is not guessing.
That's the most important takeaway. Yeah. Okay. From Nathan. Matt, do you actually close the refrigerator door with your hips?
Don't we all? How do you guys close the refrigerator door?
I kick it.
You kick it? I close with my hips. How do you close it, Robin?
I don't bother.
Robin just says, fuck it. Robin needs his energy conservation.
Honestly, it's either my hands or my dog's head. Which one of them closes the fridge door? I don't know why he likes to do it.
Yeah,
He just
so
likes to do
fuck
it.
off, Nathan. That's the
Yeah.
answer.
Okay, cool. And then this is from Benjamin. Been loving the podcast you guys are doing. It's a
We're already in
great
trouble. He
blend of
loves the
comedy
podcast.
and rocket science. One of the questions I've been thinking about is what your interest is in a big-time earthbound logistics company reaching out and buying you. Would you have a company like Maersk or another heavy hitter buy you out and use your ideas to create these products in the somewhat near future? Or do you think individuality, basically owning our own direction, is the magic to creating these solutions? Maersk is a shipping company.
Show me the money.
Robin can get
Robin's
paid off
out whenever he can. Yeah.
I mean, I've been exploring space in one way or another my whole damn career. So like whether I'm doing it for this company or, we get bought and I get financially independent to go make another company, or whatever, like I'm going to keep exploring space one way or another. So
I think it really depends. I mean, it's not as easy as Merce knocks on our door and says, hey, we'll give you $10 billion. And then actually, Matt, you and Robin can leave and go start another company because you're now both worth $10 billion. And
yeah, no, then you're trapped.
It's actually not how it works at all. So what it really comes down
Mostly
to,
because if they offer you $10 billion.
oh no, I fired everybody, so you didn't get any of your
got it.
vesting.
Okay, cool.
Yeah, that's
I
how
was
we
just gonna
got
make
it.
sure
That's how that math works out.
The
Yeah,
company works. Yeah.
yeah,
Okay.
I got it. It
I
really
feel like
depends
you guys have had this
on
conversation
what
before.
the vision is for the people acquiring you, right? If somebody was to come to us and said like, hey, we want to go explore the universe too, but we can back you infinitely in capital and provide you access to launches or material. That's a real conversation.
No,
You
Jeff
gotta go
already
consider.
has his own company.
Me and Jeff go back a ways, and I don't know if Jeff is going to realize how great we are as a company in time to acquire us. I think we're going to pass what Jeff can afford very soon.
You mean Jeff Goldblum, right?
Yeah, obviously, it was with Will Smith on the ship,
Yeah.
of course.
No,
It really depends
great.
on
We're going to turn the Tom conversation into a Jeff conversation.
It depends on what the offer is and what they look at. I'm here to go explore the universe and see if we can change the way we think about resource allocation on Earth. And if I can maintain that, great. If I can't, then it's a pretty clear, like, I don't give a shit.
Cool. Final question. You, sir, Ashton, what do you have for them?
How am I doing?
I think that you'll be notified with your PIP pretty soon on how you're doing, and we'll have 4 to 6 weeks to fix it.
Looking forward to it.
I think we just stop paying him and that problem will work itself out.
Can we? How does that work? Can we quiet fire people? People quiet quick. Can we quiet fire? Can we just actually fire Ashton but not tell him?
I'm pretty sure there's a law against that.
Yeah. And if
What's the penalty?
getting sued?
But if he can just sue me for the wages he didn't get, like, isn't it worth the risk then?
No, I think it'd be a little bit more complicated than that. I'm not an employment lawyer, but
ChatGPT will defend us in court all day long. We got it.
well, that's
Literally the only lawyer that would.
Don't check your bank account anytime soon, Ashton, okay? Promise you're getting paid.
Awesome. All right. Well, that's a wrap. We're going to pay Ashton. Ashton, thank you for bearing with us on this.
All the posters you can
podcast.
hang.
We'll see you next week to talk about CAD simulations with Holly.
I'm off.